Well, hello everybody. It's good to be back and good to finish off our final bonus quiz for Chapter 2. Now, this is 2.6 and it is the algebra functions, and that's arguably the most abstract stuff we've had to date, the algebra of functions. And I have a three-pointer for you, three problems to work. And what I thought I'd do to sort of uh, tame this section and to show you that it's well within your grasp is I wanted to dial back to my first post to the discussion board, a little 1.1 love, in which I gave you some problems to work at the very start of the semester. And they were evaluate problems. And you guys knocked those out solidly. And in the middle of which I had this particular paragraph where I said that I claim the above skill, that is subbing in values and evaluating expressions, is the key skill of the course. You will see that as we move on. Substitution is used everywhere and it gets camouflaged up and made more complicated. And I submit to you that that's all 2.6 is at its most honest level. It is simply a double substitution problem. It is camouflage substitution. It's glorified substitution. And so I thought I would tackle this first problem along those lines. Now, they're giving us two functions, an f of x defined by this expression and g of x defined by this expression. And they want us to find f of negative 9 over g of negative 9. Now this is double substitution, and to show that I first want to find not specifically f of negative 9 over g of negative 9, but a more general form for the function f of x over g of x. And that's my first substitution. F of x is the function given or defined by this expression. And so I can replace f of x by the expression it's equal to. And so what I'm doing is I'm substituting in for this function notation the expression it's equal to. And this may be the first time in your mathematical career where you substitute in a whole expression for some notation, but that is exactly what we're doing. And the same for g of x. G of x is equal to this expression, so I can replace g of x by what it's equal to, and that's what I've done right here. And now if I said to you in the first day of class, evaluate this when x is equal to negative 9, you would knock it out. And essentially, that's all this problem is. It's an evaluation problem. And now we're specifically going to we're going to evaluate this for x is equal to negative 9. F of negative 9 over g of negative 9. And so I'm going to input negative 9 into this, and I'm going to practice safe math and enclose those negative numbers in parentheses. So I get that on top. And on the bottom I get negative 9 quantity squared plus 16. Now we evaluate, we crunch that out. 45 plus 4 is 49. And on the bottom, 81 plus 16 is 97. And 49 almost goes into 97. It's 2 49s is 98. But 97 itself is a prime number, so it doesn't break up in any factors. 49 would break up into two factors, both of which are prime, 7 and 7, but 97 doesn't crack into anything, and so I'm never going to be able to cancel, I'm never going to be able to simplify this. And so the answer is, in fact, the fraction in simplest form is 49 over 97. So we can box that and we can input that into the Math Excel program. Let me create some space here. Let me click this live and say we want 49 over 97. 49 over 97. And now let's get on to problem 2. And you can see now, I think, why I took that one slightly different step in that first problem. I evaluated f of x over g of x because I knew where we were going, and we're going to actually do that in this problem. Again, they give us an f of x, and again they give us a g of x. This time they ask us to find the domain of f of x over g of x. And so we are really warm to this task now. F of x over g of x is simply a substitution problem. And so f of x is equal to this expression, and g of x is equal to this expression. And we want to know what the domain is of this quotient, of this fraction. And so by default, the domain, we want it to be R, all real numbers. And that's because this is a math problem. There aren't any words, it's not based in any reality, or we're not modeling any reality. So the question is it R? Do we have to worry any cases? And it's true, we do have to worry the case where the denominator goes to 0. We don't care if the numerator goes to 0, it's the denominator that matters. And I think you could see that when x is equal to 2, we're going to get 0 down there. 6 times 2 is 12, and 12 minus 12 is 0. So it's all real numbers, except x can't be 2. And that would be this one right here. So let me go ahead and prepare for the third problem. Now that's the third domain problem I've done for you. And I think I cut that one a little short because the other two were expository enough. And so there's our answer for this one. And let's get on to the third problem, which was a skill review problem. And these are always good to look at. And in particular, when they involve word problems, they're even better because word problems thread the course. Every chapter pretty much has a section devoted to word problems. Now, they ask us to choose a mathematical translation for this situation, and they give us two sentences. The sum of two numbers is 18, and one of the numbers is 2 more than the other. And then they give us 3 sentences here. And I thought I'd do this one slightly different, just to show you how you can manipulate a multiple choice test. Now, I can actually solve this first one. X is equal to 20, right? X is equal to 20. And so, look, the sum of two numbers is 18. Let me say our two numbers are like this. X plus y is equal to 18. And that first one says x is equal to 20. And so what does that mean y has to be? I think you'll agree with me, y has to be negative 2. That's the only way you're going to get to 18. Well, that second sentence says what? One of the numbers is 2 more than the other. So here are my two numbers, 20 and negative 2. Is this one 2 more than this one? The answer is no. And so that first multiple choice answer doesn't work. It simply is wrong. And so we know it's not this one. How about B? X plus 18 is equal to 2. We subtract 18 from both sides and we get x is equal to negative 16. Okay, so x is equal to negative 16. What does that mean y has to be to get to 18? And the answer is going to be, well, we can figure it out. We simply solve that for y. We add 16 to both sides and we get y is equal to 34. So when x is equal to 16, y is equal to 34. And again, this second sentence here fails. One of the numbers is not 2 more than the other. It's a lot more than the other. And so, we've eliminated the first two. And so that means it pretty much has to be C because there is no D. And so let's just work with this one right here just to make sure that it all makes good sense. I'm going to solve this for x by subtracting 2 from both sides. And now I divide both sides by 2, and I get x is equal to 8. So x is equal to 8. I think you can see that y is going to have to be 10 to get 18. And so we can look at the second sentence here and see if 8 and 10 make sense. They certainly work for the first sentence. 8 and 10 do sum to 18. Is one of the numbers 2 more than the other? Sure, this one is 2 more than that one. And so that is our answer. I did it by manipulating the answer space here, and that is a technique that you can utilize on the midterm and the final. So we could talk more about that as we go on. This is the first problem where I've done that, and I'll look to do it again in the future. Okay, I hope that helps. Let me go ahead and select here C, and let's go for some verification. Submit, and green arrows all the way across. Okay, see you in chapter 3.